This is an extract from Chapter 5 of Volume 8 of Modern Railway Working, in particular the Economics of Dock Administration, and the section is coal shipping. Coal shipping at Northern and Welsh ports. As regards the shipment of coal, which forms a very considerable percentage of the trade of the country, there is marked difference in the methods adopted in the northern ports as compared with those in South Wales. The difference being due to the character of the coal and to the tidal peculiarities of the respective ports. It is well known that North Country coal is harder and will bear rougher handling with less breakage than South Wales coal, which consequently renders the shipment of the former easier. At such northern ports as Newcastle, West Hartlepool, Sunderland, South Shields and Blythe, the coal is dropped through the door at the bottom of a hopper wagon into a box or hopper fixed in a high-level timber structure, which either runs alongside of or projects into the water, and is conveyed from the bottom of the hopper to the ship's hatchway by means of a chute. The variation in the level of the vessel is met by a suitable alteration in the inclination of the chute. The chute is long and narrow, as the ship is not always moored close up to the coal hoist, as in the case of the South Wales ports. In the case of end-door wagons, a portion of the framing at one end of the hopper is lowered. The end of the wagon resting upon it sinks at the same time and gives the necessary inclination for the discharge of its contents. Full advantage is taken of gravitation working, and as a rule there is little use for hydraulic power. The breakage with this hard coal is small. Even this breakage can be reduced by decreasing the angle which the chute makes with the bottom of the hopper, and thus retarding the downward rush of coal. When the ship is high out of the water, namely when there is little or no coal in her, this angle is more acute, and owing to the chute being lifted higher, the coal is checked in its descent. On the other hand, the drop into the hold is greater. When the chute has been lowered to accommodate the lower level of the ship, the downward flow of coal is more rapid, but the fall into the hold is less, and consequently the character of the whole cargo as regards breakage is much the same. The harder nature of the coal is apparently also responsible for the absence of screening. This may also account in some measure for weighing at the point of shipment being dispensed with, except at Birkenhead and Liverpool. The great range of tide in the Bristol Channel makes docking a necessity and reduces the period in which vessels can enter and leave the dock. Although, as already pointed out, this drawback is being eliminated by the provision of deep water entrance locks, of which that now in the course of construction at Newport is the most modern example. At the northern ports, the rise and fall of the tides is much less. In some cases the docks have no locks and may be regarded as artificial harbours. The question of the selection of the best form of tipping appliances is one which is largely governed by the physical conditions. For instance, the coal tips at Barry and Penarth work well and economically, owing to the existence of naturally high ground, which readily favours the formation of suitable gradients for high level working. In Cardiff, where the land adjacent to the docks is flat, the best arrangement is undoubtedly a combination of high and low level working tips and the use of coaling cranes. The high and low level arrangement is that also which has been found to be the most convenient and economical at Newport. Whatever the particular method of tipping that may be ultimately selected, there are at least three essential factors which must be met in order to achieve success. These are expeditious working, a sufficiently high lift to bunker large vessels, and as little breakage of coal as possible. Coal hoists and tips at Newport. A short description of some of the latest types of hoists in use at the Alexandra Docks Newport cannot fail to be of value to those interested in the shipment of coal. There are at present 22 coal hoists in all, of which 3 are movable and 19 fixed. Of the latter, 10 are erected on jetties extending into the dock, and 9 are erected on the quay walls. The working of the fixed tips is generally as follows. The full wagons are fed to the hoist at quay level, and the empties are returned at a higher level by gravity to the empty sidings. The method of working which applies generally to the fixed hoist is as follows. The full wagon, after being weighed, is drawn onto the turntable by a hydraulic jigger and is there turned, if required, so that the end door faces the hoist. It is then run onto the cradle, lifted by the ram directly connected with the cradle to the required height, and is then tipped to an angle sufficient to allow the coal to discharge by means of the chute into the particular hatchway at which the loading operations are being conducted. This angle varies with the different grades of coal and depends also to some extent on the weather. The cradle is then lowered to the high level, where the empty wagon is run off by gravity to the sidings. It is then lowered to key level, ready to receive the next wagon, which has already been weighed, turned and is waiting shipment. The full or feeding roads are also arranged so that the wagons run towards the hoist by gravity. In commencing to load a vessel, it is usual to tip the first few trucks into an anti-breakage box, which is lowered into the hole and emptied until a cone is formed. The 4 coal hoists erected in the south dock extension have a lift of 60 feet above the coping of the pier and are designed to accommodate wagons of a gross weight of 23 tons, but provision has been made in the hydraulic cylinders to enable wagons up to 30 tons gross to be dealt with if required at any future time. These hoists differ from those previously described in that the cradle, working in slides, is lifted by 2 wire ropes from inverted cylinders arranged in the side of the hoist structure. The hoists are provided with 2 cranes, one on each side, of 5 tons and 3 tons lifting capacity respectively, the former for anti-breakage purposes and the latter for dealing with the screenings. The method of working is the same as that already described. The spacing of the tips is a matter that cannot be too carefully considered, especially having regard to the increasing length of vessels, if the first of the essential conditions to dispatch would be secured. Breaks in the quay walls, ill-designed extensions and varying depths of water greatly delay operations by necessitating the shifting of vessels from one part of the dock to another or from one dock to another, either to enable coaling at another hatch to be carried on or to get sufficient depth of water to enable a vessel to take her full cargo. There should be sufficient room to make it possible to load all hatches without having to move the vessel to another berth, or without rendering an adjacent hoist idle. Berths so situated and of such size that the vessels using them frequently overlap the entrance and have to be removed every tide to permit vessels to enter and leave are also a fruitful cause of serious delays. Traverses at movable hoists. The 2 new movable hoists on the west side of the north dock are also designed to accommodate wagons of a gross weight of 23 tons, and similar provision has been made to enable wagons up to 30 tons gross to be dealt with at a later date. The total lift is 50 feet from rail level. A special feature in connection with these hoists is the design and arrangement of the traverses, which greatly facilitate dispatch. These traverses have a travel of 200 feet each, which enables the hoists to be worked at any point within that range. They are moved by hydraulic cylinders at either end of the travel. The traverser is first placed with full tipper, opposite the full running in line of rails where it receives the loaded truck. It is then drawn to the hoist, where the full wagon is run onto the hoist cradle by means of a hydraulic ram at the back end of the tipper. This ram is fixed horizontally and is operated by displacing the water which is in another cylinder placed at the end of the traverser nearest the hoist. The end of the ram is just flush with the side of the traverser when the tipper is down, having been driven full out by the weight of the falling tipper displacing water or oil from the tipping cylinder. The fluid in these cylinders in working passes backwards and forwards from one cylinder to the other and is operated by a horizontal ram on the main hoist frame, which is worked by the man on the cradle. While the truck is being lifted, the traverser is moved to bring the empty tipper opposite the descending cradle rails. The empty truck is run onto the empty tipper by the falling hoist tipper, the rails of which have sufficient rise at the front end to start the empty truck directly the stop is released. The traverser is now drawn back to the full and empty roads, which is a fixed position. The empty truck is run off the tipper by a tipping ram in the key ground in the centre of the back end of the empty tipper. In the meantime, another full truck is run onto the full tipper, ready for a repetition of the foregoing operations. The traverser can be automatically stopped at any position. All the movements, lifting, tipping, hoisting and slewing of the 3-ton and 5-ton cranes are under the control of one man in the elevated cabin. The chute is capable of reaching a distance of 22 feet from the face of the quay and is provided with screening bars and doors for double screening. Anti-breakage boxes. It is now almost a universal practice to provide appliances at coal shipping ports to prevent or largely minimise the breakage of cargo coal. This precaution is more particularly necessary in the case of the friable coals from the South Wales coalfield, but it is gradually finding favour also at the coal shipping ports in the north. The mechanical means by which this desideratum is effected may vary to some extent in design, and may be more or less successful in reducing or preventing breakage, but in any case it is the usual practice when loading a vessel with coal to lower a certain quantity into the hold of the ship by means of boxes which are loaded from the chute and then lowered to the requisite depth and discharged. This method is carried on until a sufficient quantity has been piled up to form a cushion to receive the coal when delivered direct from the loading chute. The anti-breakage box that was formerly in general use at the South Wales ports had a capacity of about 40 cubic feet and was constructed with a square opening at the top, with the bottom formed at an angle of about 50 degrees, provided with a front door hinged at the top of the box and secured at the bottom with a bolt having an eye formed at the top to which was attached a rope. The end of the rope, which was usually secured to one of the stanchions at the ship's side, was adjusted so that when the box had descended into the hole to the required depth, the bolt would be released and allow the coal to discharge into the hold of the vessel. The great drawback to this arrangement was that it required the services of a large body of trimmers to guide and control it, as when in operation it was always violently oscillating except when controlled by ropes by the men stationed around it. This drawback caused a great deal of the coal to miss the box entirely when being filled. Then, again, the chute doors were controlled by block and tackle, the end of the rope being held by a dozen or so men, and the closing of these doors when the box was full was often very tardily and inefficiently done, with the result that a large quantity of coal was run onto the box after it was full, and as a natural consequence overflowed and fell into the hold and became broken. It will be readily understood that this method, even when working at the best, was a very slow and tedious performance, and the result in practice unsatisfactory. With a view to improving on the then existing methods, the Alexandra Company's mechanical engineer in 1907 invented the patent box, which in practice fulfills all that is required. The maximum fall from the mouth of the chute, even with a box having a capacity of 3 tons, is only about 3 feet, and this for only the first few hundredweight. It will be noticed that the box, when being lowered into the hold, is controlled and guided by side ropes, which also efficiently control it when being again raised to the nose of the chute. Further, the chute doors are operated mechanically by a self-closing valve, and when the box is full, the operator simply releases a rope held in one of his hands and the doors close immediately, thereby preventing any overflow of coal. When the box is lowered down the hold to the required distance, the same operator applies the brake to the side rope barrel shaft fixed in the centre of the chute by simply pulling a rope attached to the brake lever, which, as soon as applied, causes the box to open and discharge its contents into the hold, the crane being lowered till this is completed. The box is then raised again to the nose of the chute for another supply. These few simple movements are operated by the hoist man with the crane, and one man standing by the side of the hatch, who operates the chute doors by means of the rope mentioned, and the opening of the box when it has descended the required distance into the hold of the vessel. These operations are performed with dispatch, and by the use of this pattern box, tipping operations can be carried out at the same speed as when the use of the box is dispensed with after the cone of coal is formed in the hole. Conveyor belts for coal. One cannot dismiss the subject of coal shipping without a reference to the new coal shipping appliances which have been introduced by the North Eastern Railway Company at the Hull docks. The new appliance consists in the application of the belt conveying principle to coal. The first appliance of this particular type of coal conveyor was at the Victoria dock, and Mr. T.M. Newell, the dock engineer who was responsible for its introduction, is to be congratulated on having demonstrated the great possibilities of this method of shipping coal as compared with the time-honoured and trusty appliance, the hydraulic coal hoist. Two of the new appliances have been erected at the Victoria dock, side by side on the same jetty, each appliance working independently into ships lying on either side of the jetty. The appliance consists in the first place of a patent hopper fitted with two hydraulic rams for tipping end-door wagons from either end. This obviates turning the wagons. Bottom door wagons can of course also be dealt with very easily. The hydraulic ram which tips the wagons also lifts the rail back so as to give clear delivery into the hopper. After being emptied, the wagons run by gravity down an incline clear of the loaded wagons onto the empty wagon line, a continuous stream of loaded wagons being kept moving over the hopper. From the hopper, the coal discharges onto an inclined rubber-covered belt 3 foot 6 inches wide, running along the jetty parallel to the ship. This belt, which travels at any speed up to 400 feet per minute, carries the coal to about 30 feet above the water level. The coal is then transferred by means of a short curved chute to a second belt running at right angles to the jetty, which delivers the coal direct into the hold of the vessel. The end of the second belt can be raised or lowered to suit the height of the hatchways of the vessel being loaded, or swung horizontally along the hatchway without stopping working, the necessity of moving the ship thus being avoided in many instances. It has been found that the steady supply of coal at the same rate assists the operation of trimming and, in addition, saves breakage to a remarkable degree. The belt is capable of shipping coal at the rate of over 600 tons per hour. The motive power is a gas engine installation, but of course electric power could equally well apply. Since the first belt was installed at the Victoria dock, Mr. Newell has got out plans and model for a further development by the addition of an anti-breakage plate which is placed in position automatically as the wagon is being tipped, forming a continuous slide from the end of the wagon through the hopper onto the belt, without the need of the coal falling or dropping into the hopper. The Hull and Barnsley Railway Company have also recently adopted this method of shipping coal, having erected 2 electric belt conveyors on their new Riverside pier. Each of these conveyors has a potential shipping capacity of 600 tons per hour. They have been designed with the object of rapid shipment, of reducing the work of trimming in the vessel's hold, and of minimising breakage. The coal is tipped into a hopper on shore and conveyed 400 feet on an endless rubber belt to a telescopic spout that reaches within the hatchway of the ship's hold and works with a lateral movement. There are also a number of belt conveyors in use at West Hartlepool, and one has recently been erected at Port Talbot. In fact, this method of coal shipping is rapidly gaining favour, and no doubt in the near future we shall see a great many more installations of this kind. While the application of the conveyor belt principle to the hard coals of the north, as shipped at Hull and West Hartlepool, has apparently given satisfactory results, the problem of adapting it to the more friable coals of the South Wales coalfield has yet to be solved. Moreover, excellent in theory as this method appears to be on the side of efficiency, and it is an ideal one where the shipment of hard coal can be carried on continuously, there are many factors at some ports, such as trimming, mixing, boxing, weighing and re-tearing of wagons, which make the operation of coal shipping somewhat intermittent, so that not only would the belt's conveyor high maximum capacity be a doubtful advantage, but owing to the frequent stopping and starting of this electricity worked contrivance to meet the special conditions, would actually become a disadvantage from the point of view of wear and tear. Again, although the first costs may be smaller, the operating and maintenance costs are likely to prove higher than those of an up-to-date hydraulic hoist installation. The speed of working by the latter method compares very favourably with the belt conveyor, and it has at least this great merit that it is absolutely reliable